Hello everyone, I am Saptarshi and in this video we will discuss the solutions from Codeforces Contest Round 801 and for Div 2 and Epic Institute of Technology. So let's get started. So now we'll discuss the first problem from the contest, which is Subrectangle Guess. The problem says that Michael and Joe are playing a game. The game is played on a grid with n rows and n columns filled with distinct integers. We denote the square on ith row and jth column by ij and number there by aij. Michael starts by saying two numbers h and w. Then Joe picks any h cross w subrectangle from the board without Michael seeing. Formally, an h cross w subrectangle consists of some square AB where a is less than the constraints are given, and it contains all squares for I from a to a plus h minus 1 and j from b to b plus w minus 1. So basically, like just contiguous cells form a subrectangle. So after Michael gives the dimensions of a subrectangle, Joe picks a subrectangle of that particular dimension, any subrectangle of that dimension, when Michael doesn't know which subrectangle Joe has picked up. And after that, without Michael knowing which subrectangle Joe has picked up, he has to guess the maximum number in the rectangle. And if he gets it correct, he wins the game. But since it's already said that Michael doesn't know which subrectangle Joe has picked up, so he can't guarantee that which number is the maximum in that particular subrectangle. So because Michael doesn't like big numbers, he wants the area to be chosen subrectangle to be as small as possible, while also guaranteeing that he wins, not depending on the Joe's choice. So we have to help Michael find out the minimum possible area of the subrectangle. Okay. So one obvious reason is that to give such a subrectangle to Joe, such that Joe picks up that subrectangle of the particular dimension, and it always contains the maximum element in the entire 2D array, right? So in this example given, the maximum element is 16. So what Michael can do is that he can give such a dimension such that no matter what subrectangle Joe picks up by of that dimension, it always contains the value 16, right? So but another thing is that he wants the area to be minimum, so otherwise it doesn't make sense, because like I can always give the entire 2D array as the subrectangle. Like say it is a 4 cross 4, I can always give the value to be h to be 4 and w to be 4. So if h is 4 and w 4, Joe has no other option than to pick the entire 2D array as a subrectangle, and I can guarantee, right, that the maximum element here is the 16, which is the maximum entire 2D array. So but I also want the subrectangle to be as small as possible. That is like h into w, the area of the subrectangle to be as small as possible. So how to figure it out? Like now I have to find h and w such that no matter what h and w Joe picks up, it always contains 16. So I find out the index of 16 here, which is what, like it is in the second row and third column, right? So I can see the 16, the distance of this particular index from the left and right edges. So I can see from the left and right edges, 16 is what? Third from the left and second from the right. So what is the maximum of 3 and 2? The maximum 3 and 2 is 3, right? So from the vertical edges, vertical boundaries, this sixth element is at maximum of distance 3. Similarly, if I pick the like horizontal boundaries, the top and the bottom, it is second from the top and third from the bottom. So maximum of these is what? 2 and maximum 2 and 3 is 3, right? So I can say a subrectangle of 3 cross 3, no matter what subrectangle Joe picks up of size 3 cross 3, I can always guarantee that 16 will be there. You can check it out. Like if I consider this to be a subrectangle, I can guarantee that 16 always contains it. I can choose this subrectangle 3 cross 3, 16 always there. This one 16 always there. This one like 16 always there. Any subrectangle of size 3 cross 3, 16 will always there. So basically the crux of the problem is to find the minimum subrectangle which like where the maximum element lies. So how, and we can find it out the maximum distance from the horizontal boundaries and the vertical boundaries. So yeah, this was about the problem A. Let's see the code. So I am just taking the input here, and I am picking the maximum element to be infinity, and this part of the code basically checks finds out the coordinates of the maximum element in the 2D, and there will be only one maximum because it said that the grid is filled with distinct integers. So after I find out the coordinates, I am storing it in x and y variables. So the length of the subrectangle will be maximum value of from distance from the left and distance from the right, and similarly the width will be maximum of the distance from the top and the distance from the bottom. So once I find out the length and width of the subrectangle, I have to print the area, which is L below. So this was about problem B. So let's move on to problem B, circle game. It says Mike and John playing a game with some stones. Specifically, there are n piles of stones of sizes A1 to AN. These piles are arranged in a circle. The game goes as follows. Player takes turn removing some positive number of stones from a pile in clockwise order starting from pile 1. Formally, if a player removes stones from pile I on a turn, the other player removes stones from pile I plus modern plus I modern plus 1 on the next turn. So basically 1, 2, 3 till n, and after n it again turns back, goes to 1. So, and if a player cannot remove any stones on their turn because the pile is empty, they lose. And Mike goes first. And the game starts from the pile 1. If Mike and Joe play optimally, who will win? Alright. So this question requires some observations. So let's start with it. Say let's divide the problem into two cases. Say n is even and n is odd. Say n is odd. Say n is odd. Right. Say n is 5. So there are 5. So what happens here? So this particular, what happens is that Mike starts the game and Mike starts picking some stones from the first pile, right? So this particular pile goes, Mike will choose. This particular pile in the next turn, Joe will choose. This Mike will choose. This Joe will choose. This Mike will choose. Again, then this pile Joe will choose. This Mike will choose, and so on. It will go on, right? So one obvious strategy of Mike is that Mike will turn this empty this pile in the very first turn of his very first turn. Mike will completely empty this pile, right? He will make it 0. So what will happen? It doesn't matter what other steps they do. Like say Joe removes something, some number of stones from his here. Mike again does something. Joe again does something. Mike again does something. It doesn't matter. Once all of these iterations is done, after the entire first round of the iterations is done, when it comes back in the second iteration, now it is Joe's turn, but Joe sees that this pile is empty, right? So he is the first person to see an empty pile, so he can't make any move, and hence Joe loses and Mike wins the round. Because, and in the first iteration, in the first round of iterations, none of them will none of them will encounter an empty pile in the very beginning, because in the constraints it given that a1 to n and ai is greater than or equal to 1. So initially every pile has at least one stone. So in the very first iteration, no one will encounter an empty pile from the very beginning, right? So after the first iteration, when in the second iteration Joe comes and sees this is an empty pile, because Mike has already emptied it completely in the very first round. So he's the first person to see an empty pile, he can't make any move, Mike wins the game. So an obvious strategy for Mike is to empty the first pile in his very first game. So this is the case when n equals to odd. So when n equals to odd, Mike always wins the game. Now comes the case when n is even. Now comes the case when n is even. Since I say n is equal to 6, right? Let's go on with n equal to 6. So when n equals to 6, what happens like in the first round of iteration? This pile Mike chooses, this pile Joe chooses, this pile Mike chooses, this pile Joe chooses, this pile Mike chooses, this pile Joe chooses. In the second iteration, the Joe chose this pile, again Mike chooses this pile. Joe, Mike, Joe, Mike, Joe. And in the third iteration again this Mike and so on. So in every round we can see that a particular pile will always be picked by a particular player itself. Say like the first pile, only Mike will choose. Joe it will never come a turn when Joe picks from the first pile. Third pile always Mike chooses. Fifth pile always Mike chooses. So every alternate pile only Mike will choose. And like every odd pile only Mike will choose. Every even indexed pile only Joe will choose. Right. So basically we can kind of say that each pile belongs to a particular person. This pile belongs to Mike, this pile belongs to Mike, this pile belongs to Mike. Why belongs? I'm saying belongs because like only Mike is removing from this pile. Joe will never get to remove from these piles. So since Mike and Joe both know that this particular pile from which I will remove will always belong to me only. Like Mike will never get to pick from this. Only I have to remove from this. So each of them won't want to make that their pile empty, right? Because if they make that pile empty, they will only have to encounter that their particular pile, right? So if they make the pile empty, and the next iteration, next round of iterations, I will face that my pile only to be 0. So I will lose the game, right? So, but they have to remove some number stones. They have to remove some positive number stones. So each of them will play optimally, and each of them will remove exactly one stone from the pile, because no one will want to make their pile empty in the like early on. Everybody will keep on continuing with their piles, keep on having some stones in their piles till the very end. So at the very least, they will remove only one stone from each pile, their pile. So, but if they continue keeping on removing one stone from the pile, we have to see that which particular indexed pile will be finished first. Say like we have to find out the minimum element from the array, right? Say this is 7, 6, 1, 2, 10, 8 and say 4, right? So we can say here 2 is the minimum index. So in first iteration everybody will remove one stone, so every element will be reduced by 1. In the second iteration again every element will be reduced by 1. After second iteration we can see that this 2 will turn to 0, right? Because first iteration 1 stone removed, second iteration 1 stone removed, so it will become 0. In a third iteration Mike will encounter this pile and you will see a 0 stones in this pile. Mike will not be able to make a move, so Joe wins the game. How did we decide that Mike will be the first person? Because this is the minimum element in the array and this pile belongs to Mike, right? So this is the minimum element. Since it belongs to Mike's pile, Mike will be the first person to encounter a 0 stone pile, and hence he will lose and Joe will win. But another case is that what if there are more than one minimum element? Say this will not also. Then there are 2 minimum elements, right? So in this case, after the second iteration, both will become 0. Because if they keep on removing one stone from each pile, after the second iteration both of them will become 0. But in the third iteration, before Mike, Joe will find this pile to be 0. So Joe won't be able to make a move, and hence Mike will win the game. So not only the minimum element, we have to find the index of the first occurring minimum element. So here the minimum element is 2. I will have to find the index of the very first occurrence of 2. So if this very first occurrence of 2 belongs to Joe's pile, Joe will lose. Or if it belongs to Mike's pile, Mike will lose. Right. So, and how do we determine whether like it belongs to Joe's pile or Mike's pile? Similarly, like this parity. So if I consider 0 indexed based array, so even indexed pile belongs to Mike and odd indexed pile belongs to Joe. Right. So this is the core of the problem. So yeah, so this is the I'm taking the input. So this is the first case when n is odd. So when is odd, I've already explained that Mike has a strategy to remove the front pile, remove everything from the front pile, like first pile, and hence he'll win. So I'm printing Mike and return. And from here it is guaranteed that n is even. So this part of the code finds out the minimum index, like index of the minimum element, and if there are multiple minimum elements, I am finding out the first occurring minimum element. So after this particular for loop, ind will store the first occurring minimum element, and if this is an odd index, which means it belongs to Joe's pile, Joe will lose, winner is Mike. And if it is an even, so I am printing Joe. Like, because why Joe? Because it belongs to Mike's pile, Mike will lose, and hence Joe will win. So this was about problem B. Let's move on to problem C, zero path. It says you are given a grid with n rows and m columns. We denote the square on the ith row and the jth column by ij, and the number there by aij. All numbers are equal to 1 or minus 1. You can start from the square 1, 1, which is the top list cell, and can move one square down or one square to the right at a time. In the end, you want to end up at the square nm, which is the bottommost right cell. So it's asked us, is it possible to move in such a way so that the sum of the values written in all the visited cells, including the first and the last cell, is 0. So the example is shown over here. Say this is a 3x4 grid. So if we move along the path shown in red color, what is the sum of the path? What the sum of the path is 1 plus minus 1 plus 1 plus 1 plus minus 1 plus minus 1, which is 0. So the sum of this path is 0. So we want to find, we are asked to find it, does such a path exist such that the sum of the path is 0. So okay, so first thing to observe is, if we want the sum of the path to be 0, the number of 1 in the path should be exactly equal to the number of negative 1 in the path, right? Only then the 1s and the minus 1 can be cancelled. So basically, in other words, we can say that the length of the path should be even, because if the number of 1s is equal to the number of negative 1s, the total length of the path should be even. So the total length of the path should be even. Okay, cool. So if we are given an n cross m grid and we have to move from the topmost left cell to the bottommost right cell, then what is the length of any path which is taken and starting from the topmost left to the bottommost left? In an n cross m grid, the length of such a path will always be n plus m minus 1, right? So you can very well verify with this example. Here n is 3 and m is 4. So n plus m minus 1 is 3 plus 4 minus 1, which is 6. So the length of any path starting from this topmost left to bottommost right is 6. Say like this length of the red path, you can see it is length 6. If we move along here, it is 6. If we move along this edge and this edge, this length will also be 6. So any path length starting from this topmost left to bottommost right will be 6. So this n plus m minus 1, which is the length of this path, has to be even. So n plus m minus 1 has to be even. Otherwise, like, it's guaranteed that we cannot find a path whose sum is 0. So this path length should be even, n plus m minus 1 should be even, and hence n plus m should be odd. So the very first condition that we should check is, if n plus m is even, then we cannot do. If n plus m is odd, then we might exist a path, not guaranteedly existing, but might exist a path. So if n plus m is odd, then how to check? So for that, I am copied this example to the signboard. So for this, I'll create another matrix where each cell will kind of store all the possible values, also the possible sum of the path till that cell, starting from this topmost left cell. So let me explain what I am saying. So here, say if I'm starting from this cell and I want to reach this cell only, what is the sum of the path? The sum of the path is 1 itself, right? So sum of the path is 1. Say I want to move to this cell, from this cell only, I want to move to this cell. There is only one path. What is the sum of the path? 1 plus minus 1, which is 0. So I write 0. So I say I want to move to this path. There is only one path. Right? Again right. What is sum of the path? 1 plus minus 1 plus minus 1, which is minus 1. Say I want to move to this path, this cell. Only one path possible. What is the sum of the path? 1 plus minus 1, minus 1, minus 1, minus 2. Similarly, I say I want to move to this cell. Only one possible path. What is the sum? 0. Say I want to move here. Only one possible path. 1 plus 1, 2, 2 minus 1 is 1. Right. Now comes the interesting part. Say I want to move to this cell. There are two ways I can move. Either I move from here, move to this cell and then move right. Or I move to this cell and move down. So this cell, if I move to this cell, the possible path values are only 0. If I move down, I add 1. So 0 plus 1, I can reach 1. Similarly, if I move here, the possible path values is 0. I move right, so I encounter 1. I add 1 to all the possible path values. So 0 plus 1, which is 1. But 1 is already added over here, so it's fine. Now, if I want to move to this path, move this cell. Similarly, I can again move from here to right or this cell to down. So if I move to this cell to down, what is the possible values? Possible path values is minus 1. I move down, I add 1, minus 1 plus 1, 0. Right. If I move from here, if I come from here and move right, in this cell, what are the possible values? Path values? Possible path values is only 1. I move right, I encounter 1, I add 1 to this existing path value 1. So 1 plus 1, 2. 2. So what does this tell me? If I move to this path, this cell, all the possible path I can take, I can get a value of 0 or 2. So this is a set of all the path values which I can get if I reach this cell, starting from this cell. So from this cell to this cell, of all the possible paths, I can get 0 or 2 as a path. So if I want to move to this cell, what I can do, I can either move right or either move down. If I move down, this is minus 2. I move down, I encounter minus 1, I get minus 3 over here. If I move from here to right, for here this cell, I've already got 0 and 2. If I move right, I encounter minus 1, I subtract minus 1 from here, so 0, 2, I subtract minus 1 from both, I get minus 1 and 1. So minus 1 and 1, I add to the set. So if I reach this cell, from this cell, all the possible paths, if I check, I can get either value -3, -1 or 1. So now I move to the cell. Similarly, I can either move right or down. If I move down, this will be 1 plus 1, 2. Here also, if I move right, 1 plus 1, 2. Now checking for this cell. If I move right, 2 plus 1, 3. If I move down, 0, 2, I add 1 to each of them. It will be 1 and 2 plus 1 will be 3. 3 is already added, so it's fine. Now encounter -1. For -1, if I move right, this cell is already 1, 3 path values. Encounter -1, I subtract 1 from both of them. I get 0 and 2. So I add 0 and add. Say I move down, -1, all the possible path values is what? -3, -1, 1. I move down and encounter -1, I subtract 1 from 1. What are the possible path values? 4, -2, 0. So 4 is not here, I add 4. -2 also not there, I add -2. 0 is already there, so I don't need to add it. See, so in this cell, what are the possible values I can get? I can get -4, I can get -2, I can get 0, I can get 2. So see, I can get 0 over here, right? So there exists a path like where the path sum from here to here is 0. So my answer is yes. But so one way to implement this is to, like, for each and every cell you find out, like, do kind of brute force and find out all the possible values, like I've solved it here, and check if in the n comma m cell if 0 is such a possible value. So but it will give you time limit exceeded because of the time limit you choose. N cross m is 1000 each, so the maximum can be 10 raised to power 6, but for each of the cell at max the size can be n. So if you iterate over each cell's n possible values, then it will be like order of 10 raised to power 9, which will be like not possible. So we have to optimize on this. So one thing, if you guys notice can notice here, is the difference in each of the cell, whatever possible values, the difference between the consecutive values is always 2. See, this, like in this cell 0, 2, the difference is 2. In this cell -3, 1, 1, difference is 2. This cell -4, 2, 0, 2, difference is 2. Always 2. Like not more than 2, not less than 2. Exactly. So how is this like actually possible? So basically, if you choose a path, say this is the path you encounter, right? So this is the final cell, this is the initial cell. If you move to another cell, choose another path, say you choose this, let me change colors. So in these two paths, what is the difference? Difference is only in the red cells, right? Rest all are same. Only the red cells are different in these two paths. So what is the worst case that can happen? That both of the cells contain different numbers, say 1 and -1, or -1 and 1, vice versa. So what is the absolute difference in the sum of the parts of these two parts? The absolute difference will be 2, right? Like all the rest of the cells are same numbers, only these two are differing and they are different. So 1 and -1 difference is 2. So basically for all the parts you can get at most difference of 2, and hence at most a difference of exactly 2, or difference of 0 if, like, say both of them have the same values, say 1 and 1 itself. So the difference in this case will be only exactly 0. So either the difference does not change, the sum of the path does not change, or it changes but exactly. And this is the reason why we are getting the possible paths of each cell at the difference of intervals of exactly 2. And also another thing, we can see that the parities of the possible sum which we get is uniquely defined, can be determined by the parity of the cell. What do I mean by the parity of cell? Say this particular cell, if I go by 0 index, it will be like I equals to 1 and j equals to 3, right? This is the 1,3 cell. So in 1,3 cell, I plus j is what? I plus j is 4, I plus j is 4, and 4 is even. So this cell will have odd numbers. Absolute value will be odd. So, and here I is 2 and j is 3, so I plus j is 5, 5 is odd, and since 5 is odd, these values are even. So like basically I can check over I plus j and parity of I plus j, and using the parity of I plus j I can determine what will be the parities of these numbers. So, yeah, so the main crucial thing is that the difference of the possible sum of the parts will be exactly. So I don't need to store all the values of these, right? What I can do, I can simply store the minimum possible sum and the maximum possible sum. If I get the minimum possible sum as -3 and the maximum possible value is 1, I already know that every value from 3 to 1, -3 to 1 at intervals of 2 are possible. Similarly, for this cell, I can store -4 and 2, this, just simply like this. Then I can say that every number from -4 to 2 inclusive at intervals of 2 are possible. So for that, what I can do, I can store instead of storing some multiple numbers, I can store the minimum and maximum itself. So here, instead of 1, I can write the minimum as 1 and the maximum is also 1. For here, I can write minimum 0, maximum 0. For here, I can write minimum -1, maximum -1. For here, -2, 2. So like basically I am writing these as tuples because I want, like, the first number represents the minimum possible value, and the second number represents the maximum possible value. So this is 0, 0, this is 1, 1, this is 1, 1, this is 2. Now for this cell, see, for this cell what will happen? This cell, it is 1. I will choose the minimum of these two. The minimum of these two is -1. Or -1, I will add 1 to get 0 as the minimum value. For the maximum value, what I can do, I can choose the maximum of these two. The maximum of these two is 1, right? For 1, I will add 1 again to get 2. So this is how I can get the entire interval. Similarly, let's do for another one. So for this cell, I can move to right or down. For right, I can choose the minimum of the left element of both. What is the minimum? Minimum is -2. On -2, I add -1 to get -3 as the minimum element of this. For the maximum element, I can choose the maximum rightmost element of this 2, which is 2. On 2, I add -1 to get 1. So this will be the interval, right? So -3, 1 is interval. That means -3, 1, -3, -1 and 1. All three are possible. So here, this is 1. This is the interval. This is also interval. What is the minimum left element? Minimum left element is 0. On this, I add 1 to get 1. What is the maximum right element? 2. 2 and add 1, I get 3. So 1, 3. This is the interval. Here, which is the minimum left element? Minimum left element is -3. On -3, I add -1 to get -4 as the minimum element. And what is the maximum right element? The maximum right element is 3. On 3, I add -1 to get 2. So this is the interval. So this is the interval, which means all the elements from -4 to 2 and steps of 2 are possible for this cell. So basically what we can do, instead of this storing it as tuples, I can store 2 different matrices, and for each matrix, one matrix for storing the minimum and one matrix for storing the maximum. For these, once I store these 2 matrices, declare these 2 matrices, I can store the values in these 2 matrices as I mentioned over here. Now I can say that for this particular cell, if 0 contains in this, then I can say that it's possible, right? Because see, -4 to 2, so it is -4, -2, 0, 2. So 0 contains in this interval. I can say 0 contains in this interval. So there is a possible path with some 0. If 0 does not contain here, say this interval would have been like 1, 2, 5, like this, something like this. So 0 does not contain in this interval, right? So since 0 does not contain in this interval, I can say that there does not exist a path. So this is about this problem. Let's move to the code. So this is the code. This part is just the input part. I have stored the minimum 2D, like one 2D array for the minimum, one 2D array for the maximum. I am declared, and now I am tabulating this minimum and maximum 2D array. Like the DP, the recurrent relation, is minimum I comma j is the minimum value of the left and the up minimum of those two, and to that minimum I am adding 8ij. Similarly for the maximum, I am calculating the maximum of these two, like you can say, like for say this value, I can calculate the maximum of these two, which is maximum 3 comma 1, which is 3. On 3, I am adding aij to get the maximum of I comma j. And finally I am saying that if the minimum is less than or equal to 0 and maximum is greater than or equal to 0 and the n plus m is 1, right? Because I already told you before, like n plus m has to be odd, then only I can get a path of even length. So if all these conditions satisfy, I am printing yes, else I am printing no. So yeah, this was about problem C.